Hello, welcome to video 2 of regression analysis. In this video, I'm going to talk about mathematical modeling. So let's start. Whenever we collect the data set, we would see a bunch of variables in the data set. And the first job is to find out what is the main variable of interest, which we call as dependent variable, which is the effect, and what are the other influencing factors, which we call as independent variables in the data set. Using the same example from the last video, imagine you are a teacher and you have a data set from a class full of students you teach. Let's say data contains the students' study hours, sleep hours, attendance, exam scores, if they had exam anxiety during exam time, so on and so forth. So the first job is to identify what is the dependent variables, and the exam score would be treated as the dependent variable. And all the other variables present in the data set are independent variables. Now our goal is to create a regression model. But before we try to understand the regression model, we should know what does it mean to say that we want to create a model between these variables present in the data set. Say you have all this information and now you want to create the model. In simple English, modeling refers to the development of mathematical expression that describe, in some sense, the behavior of a random variable of interest. This variable of interest is called the dependent variable, or it has several other names such as response, output, outcome, and throughout whenever we see the dependent variable, we'll just give it a notation y. We just denote it by letter y. So whenever we see this letter y, it means that we have a dependent variable in the model. Now, in the example above, the exam score is the dependent variable. And now, our goal is to come up with a mathematical way to describe how these exam scores change based on all the other influencing factors. So mathematically, this is the equation we would have. Y is equals to f of x plus e. And this looks very fancy, right? So let's break it down and see what does this equation, what does all the letters in this equation means. So on the left hand side, we have this letter y, and y is the dependent variable. And then we have a letter x, and this x is the independent variable. We all know what independent variable and what dependent variable means. The next thing we have is the function f. What does this f means? We know that x and y are related to each other. As you change the value of x, the value of y, dependent variable, is also going to change. So the dependent variable is its value is completely dependent on the independent variable, which means they are associated to each other. They have some sort of relationship. Y is a function of x. That's why when you are changing the value of x, the value of y is also changing. So this f is a mathematical way to describe the relationship between the exam score and those other influencing factors called as independent variable. And then we have this last term e, and e is called error term. So we know what y is, we know what x is, and we know that y and x are in some way related to each other. So this function f entails how x and y are related to each other. We don't have much information about this error term. Let's try to understand what this error term actually means. For each student, you have their exam scores, the number of hours they studied, the number of hours they spent on social media, and maybe even a measure of how difficult the exam was. You collect the data set, you have all these information for each student. So now we have the dependent variable and we'll give it notation y. We will always denote it with the letter y. So here exam score is the dependent variable and we denote it by letter y. And then we have other independent variables And whenever we are defining independent variable, we just denote it by letter X. Since we have more than one independent variable present in the data set, in the subscript, we'll put a digit 1, which would mean that it's the first independent variable. X2 would mean the second independent variable. X3 would mean the third independent variable. So right now, let's say we have a data set that contains the information of the exam score of a student and the number of hours they studied, the number of hours they spent on social media, and the difficulty level of the exam. We have given it all this notation. And of course, one thing we know is that this dependent variable y, exam score, is actually dependent on the number of hours they study before the exam. It is dependent on number of hours they spent on social media, because if they are spending more time on the social media, they are not working hard for their exam. They're not working hard enough for their exam, and they will not get good scores. So this exam score might be dependent on the number of hours they spent on social media. And X3 is the difficulty level of the exam. If the exam is super difficult, then the exam score might not be that great. So this value y, this value of the dependent variable, is dependent on all these independent variables. But wait, there might be some other factors that would influence the value of the student's exam score. But we don't have much information about all those other factors. For instance, say some student had exam anxiety during the exam. If they are anxious while they are taking the exam, they might not be able to perform well in the exam. Maybe the students did not complete all the practice sets or assignments before the test. If you are assigned with some practice test, you might see some questions similar to the questions you have seen in the practice test. Now, if you don't practice all the questions present in the practice test, then it will be a bit difficult for you to perform well in the exam. It might not be directly related, but it might be related, somehow related. If the practice test and if the exam have similar question, then it would be easier for you to score well. That you might score great in your exam. So all these variables are also influencing your exam scores in some way. But we don't have any information about these variables. So what do we do in this case? This is where the error term comes in. This error term, denoted by E epsilon, captures all the stuff we can't directly observe or measure, but still affects the outcome. So exam anxiety, if they finish their practice exam assignments on time before the exam, if they completed it, and all the other independent variables that we have no information about, this error term is going to take care of all those independent variables. That's why this error term is really important whenever we are trying to create any model. There are other ways also how we can understand this error term. Imagine you are trying to collect the data for the exam score of a student, number of hours they studied, number of hours they spent using social media, all these things. And when you were entering the data on your system, accidentally you press 5 instead of 6 for some random variable. Now that's a data entry error. And these small mistakes can always sneak into your data set. And this error term, again, it helps account for that. So whenever we are trying to create any sort of model, it's super important to include the error term in the model. This error term, entering it in the model, would make our model more realistic and honest about the uncertainty we cannot control. The general definition of modeling is, suppose we observe a response y and p different predictors, denoted as x1, x2, so on and so forth till xp. Now what we know is that y, the dependent variable, is related to all the independent variables present in the model. And if we want to write it mathematically, we would have the equation y is equals to f of x, which means y is related to x, plus the error term. Now here, this function f is unknown to us, Because whenever we collect the data, we would have all the information about Y, we would have all the information about X, and we would know that X, the value of the dependent variable, is dependent on the independent variables. It is there exists some relationship between the independent variables and the dependent variable, but what is that relationship? That is not known to us. So here this function f represents a fixed but unknown function of all the independent variables present in the model. And then we have this term e, which is called error term. So here, if we look at this equation, we have that y is equals to f of x plus e. So here we have two components. We have one part f of x, and we have the second part error term e. The first part, f of x, y is dependent on all the predictors, all the independent variable. Y is a function of x. This function of x is called systematic component. It tells us how the dependent variable y changes with all the independent variables present in the model. And then the second part, this error term, is called random component because it captures all the unpredictable, unobserved, or uncontrollable influences on the dependent variable. It takes care of all the uncertainties that is present in the model. Looking at the equation y equals to f of x plus e, we know that x and y are related to each other. But how are they related to each other? It is still unknown to us. So now our goal is to estimate this function f, the systematic part of the model. But now the question is, why do we want to estimate it? Why do we want to find the function f? There are two primary goals in statistics and data science when we model data: inference and prediction. Loosely speaking, what is inference? You are trying to infer something, you are trying to tell something. Prediction, meaning is you are trying to predict something, you are trying to find some value. Let's try to understand both inference and prediction with an example. Suppose you have data for the sales of a mobile phone over the past 20 months. And this data includes details like the brand of the mobile phone, its features, and the price. Now, let me ask you all a few questions. Does increasing the price decrease sales? Do certain features of the mobile phone boost the sales more than the others? Is brand A more impactful than brand B? And one more question, maybe given a new phone's brand, features, and price, can you predict how many units will be sold the next month? So what you have is you have the information of the sales of a mobile phone over the past 20 months. Here, sales of a mobile phone is the dependent variable. And all the other variables, that is the brand of a mobile phone, its features, the price of a mobile phone, all these are independent variables because all these factors are going to influence the sales of a mobile phone. Now, when I asked you all the four questions, which is, does increasing the price decrease sales? What are we trying to do? We have price as the independent variable, and we are trying to find out if we increase the value of the independent variable, would it decrease the value of the dependent variable? So we are trying to find out how is the value of the independent variable changing the value of the dependent variable. Similarly, if we look at the second question, do certain features boost the sales more than the others? So we are, again, the feature of the mobile phone is the independent variable. And we are trying to find out if this is changing the value of independent variable and how. So if we look at the first three questions, we are trying to seek how are these independent variables related to the dependent variable. We are trying to find out how are they related. What is the relationship? When you increase some value of the independent variable, is it decreasing the value of the dependent variable? We are interested in the relationship between the independent variables and the dependent variables. Whereas if we talk about the fourth question, which is given a new phone's brand, features, and price, Can you predict how many units will be sold the next month? Here, what you are trying to do is you are trying to predict the future sales for a new phone based on its characteristics. So, in the fourth question, you are not interested in the relationship between the independent variables and the dependent variable, whereas you are based on whatever information you have in the data set, you are trying to use that information to predict something about the future. One of the reasons why we want to estimate F is because we are interested in the relationship between the independent variables and the dependent variables. And inference is about understanding that relationship. Given any sort of data set, once you identify the independent variable and the independent variables in the data set, the next question you would ask is, are all the dependent variables present in the data set actually influencing the dependent variable? Because sometimes these independent variables might not be related to the dependent variable and might be present in the data set. So the first question you would ask is, which variables matter? The second question is, once you have identified which variables are actually related to the dependent variable, what is the strength or magnitude of their effect? Basically, how much do they influence the outcome? Next obvious question would be, does an increase in the value of the independent variable lead to an increase or decrease in the value of the dependent variable? So, in what direction do they influence the outcome? So, inference is all about understanding the relationships between the variables. It could be understanding the relationship between the independent variables, between two independent variables. It could be understanding the relationship between an independent variable and a dependent variable. And the next reason why we want to estimate F is the prediction. Prediction is about estimating the value of the dependent variable Y for new or future data. Sometimes you are using your model to generate accurate outcomes and not necessarily to interpret or explain the why. And the goal is to use the past data to make a good guess about the future. And that's what prediction is about. Prediction is about not explaining the relationship between the independent variable and the dependent variable. Using all the information you have about the variables present in the data set, you are using it to make any future guesses. Depending on whether our ultimate goal is prediction or inference or a combination of the two, we have different methods for estimating F. There are linear models, there are nonlinear models. Linear models allow for relatively simple and interpretable inference, but may not yield as accurate predictions as some other approaches. Whereas nonlinear model provide quite accurate predictions for Y, but this comes at the expense of a less interpretable model for which inference is more challenging. So, based on if our question is prediction or inference, we then decide to create a linear model or a nonlinear model.